Okay, this is the second lesson on one variable analysis. So this unit's all about one and two variable analysis. We're talking about measures of spread. And so this quote is actually really good from Tom Peters. Respect and reverence for the principle of variation. The idea, the message ain't in the mean, the mode, or the median. It's in the differences that occur throughout a population. And so like we're gonna actually have to see this difference or the variation in the data and look at that as well in terms of measures to analyze in addition to measures of central tendency. This is a great video. If you get a second, you can go to it. It's in the slideshow. Just to start thinking about accuracy without precision or precision without accuracy. So the idea here is accuracy is the idea that you're going to hit possibly your possibly your target. And so when we talk about validity, so sample representing the population, well, are you hitting your target? So that's accuracy. And precision is the idea that you can hit it again and again and again, and that's reliability. This accuracy and precision are really, really closely tied to validity and reliability. So it's kind of a neat review of those two concepts, which are really important in statistics. So today we're going to be talking about standard deviation, measures of spread, and comparing two related one variable data sets. So measure of spread helps you describe the variability, so how much the extent to which it's clustered around its center. So we can also say the reliability, so how consistent something is. The three measures of spread are range, IQR, and standard deviation. Range is by far the easiest measure we get to calculate in this class. But not the most easiest to calculate on a Google Sheet, so we'll see how to do that. And so looking at the 2005 the Community Health Survey across Canada, it was also conducted in 2000. We're going to look at this data and actually how to calculate it. It's just the difference between the max and the min, and so we'll do another video just of calculating the range. The interquartile range is the difference between the 25th and the 75th percentiles. So they're basically the median of the first half and the median of the last half. So that it is a range, but it ignores the top and the bottom quarters. So Q1 is quartile 1, which is the 25th percentile. Q3 is the 75th percentile. So it's the number that's in the middle. So it's actually a number. And there's some debate on the best way to calculate this. So a couple technology sources calculate it slightly differently. Not really that much difference, but once you start to talk about what is that 25th percentile, if there's no number there, some different pieces of technology calculate a little differently. We're going to use a spreadsheet, and we're not going to do it by hand. And so we're just going to imagine that it's the median of the first half, the median of the third or the second half, but we're not going to do it by hand. So we'll come back to that and do it in the spreadsheet. Standard deviation. There's 4 formulas here, and they're really they can get a little funny. So I just want to kind of talk about what this formula means. And so first we call it the variance, kind of from that idea of variability. So it's sigma squared. Sigma is the standard deviation. Sigma squared is the variance. Basically what we're doing here is we're adding up all these measures, the differences from the average, each one. And so I'll just kind of talk you through it. So it's variance and standard deviation are together. The variance is the average of the square distances. So you take the distance every point is from the average. So this mu is the average. So we use mu for the population, x bar for the sample. And so when you get every new value, you square all of them, and then add up all those and divide them by the total number of data points. And so it's basically the average of the square distances. The variance is calculated in square units, so we can't really apply it right back to the data and say, oh, this is what it means. So we take the square root and actually get you actual distances so that you can compare it to the data. So standard deviation is defined as the typical distance any given point is from the average. So when we square root the variance, we get standard deviation. to really fit the definition completely, we're really talking about normally distributed data, so data that peaks up in the middle. Um, However, we can use it for even when it's not normally distributed. So we still get this idea of consistency, um, a measure of variance still, which actually represents all the data, and the IQR doesn't. The formula for standard deviation of population looks like this. And so to calculate it, this video actually walks through calculating it step by step by hand, but I'll walk through a spreadsheet where we can calculate it step by hand as well. There's a lot going on in this slide, so a couple things have changed. This is for this sample. The sample has just changed sigma, the little circle with a line, to an S. And instead of capital N on the bottom, we've got small n. So small n is the total number of points in the sample. And then X bar is now the average. So nothing mechanically really has changed except for the n minus 1. And so a couple things that happens, like the squaring cancels out the negative values. So it allows you to have no negative values. We'll only have positive distances. But instead of just doing absolute value, or what the squaring also does is it gives points that are further away from the average more weight in the standard deviation. Points that are further away from the average create a little bit less consistency. And so we just have to make sure that if that consistency decreases, then those points are going to be actually worth more. So points really close to the average make it more consistent, so they're going to actually be worth less, and so drive the standard deviation down. Now for the n minus 1, so we know it's hard to get data for an entire population, so we use a sample of the population instead. Because the sample's smaller, it actually makes sense that the standard deviation would vary more. The data varies more. To reflect this change, rather than divide by n, we would divide by n minus 1. That actually makes the standard deviation slightly bigger, and what that does is it creates a little bit more variance in the standard deviation. So it creates it to be a little bit bigger, but we can still use smaller number of data points. That's why we only subtract by 1. That's my best explanation why we do an n minus 1. Probably a statistician would give you a better explanation, but really it just makes the number a bit bigger, so that the standard deviation is a little bit higher than it would be in the population. It doesn't make a big difference, and we'll see that from the spreadsheet calculation. So you can kind of think about when would each one be advantageous and have limitations, and there is examples of both, so I just invite you to think about that. So we're going to look at the healthcare data for year 2000 and 2005. So these are the actual measures. We'll look at how we calculate them in a minute in the next video. So a couple conclusions. The range tells you that the range actually decreased from the year 2000 to the year 2005. And so what that means is it's slightly more consistent in the year 2005. So remember that this is the percentage of people that ranked healthcare as good or excellent across the country. And so each one of these data points represents each province or territory. The IQR has actually increased a little bit. So now it is helpful to note that the Q1 and Q3 have been shifted. So they've been shifted higher. So although the IQR hasn't suggested any real improvement in consistency between the middle 50%, it does have higher numbers from the Q1 and Q3. The standard deviation, so it's the distance a typical point is from the average, and it has decreased slightly again, making it slightly more consistent. It's just helpful to note that it doesn't mean that the countries become better or worse. It just means that the data has become close together. So for example, say Nova Scotia increased to 99% in 2005. So we'll look at the actual data in the next video. But that will actually decrease the consistency, but that's a good thing for the country. So we're going to look at the data right now, how to actually create it, and we're going to remove none of it and see what happens to the data as